Okay, so the first thing we would do, and on the test I will ask for specifics. So the first thing we'll do is say, okay, first of all, cosecant is the reciprocal of what trig function? Sine. So let's just rewrite this as a sine function. Y is equal to 2 sine of 2x minus pi. And then the first thing I'm going to ask on the test is what's the amplitude? That's usually our easiest, right? Amplitude is 2. So we would go over up to -2. We would label that. Next thing is we would then look at our period, which period means physical length of one cycle. Period for this one is, well, for sine, is 2 pi divided by b, right? B is what's in front of x, remember? So that's 2 pi divided by 2, which is simplifies to be pi. So the physical length of 4 tick marks for us on this is pi, everybody. One full cycle is going to be pi. However, not only starts at 0, it has a shift, right, guys? It doesn't start at 0. So we also have to look at this inside here and say, okay, what's my shift left and right? Now remember, the 2 does affect my shift left and right. So all you have to do is set 2x minus pi equal to 0 because it would normally start at 0. Solve for x, so we would add pi. So we have 2x equals pi, divide by 2. So x is shifted right pi halves. So that's one thing to note, right pi halves. Now that's what's going to be called a phase shift, you guys. So it's called a phase shift, and that's going to be a specific on the test. It's going to say, what's the phase shift? And you're going to say right pi halves. Does that make sense? Okay, so what we're going to do is start there. So what you're going to do is say, I am now starting over here, shifted over at right pi halves. So that's what we're going to, I'm going to draw in a new y-axis here. Okay, awesome. So now we have to draw in 2 full cycles. So what you're going to do is do all your tick marks. So out 1, 2, 3, 4. Now from here to here is pi, right? That's pi in units. So you'll take pi halves plus pi, which will put us at 3 pi halves, right, everybody? Okay, let's find the halfway mark. So 3 plus 1 is 4 pi halves, right? I'm going to find the halfway mark. We've got to label this all correctly on the test. So 3 pi halves plus 1 pi halves is 4 pi halves, which is 2 pi, right? But then we're dividing it by 2 to get the halfway mark. So that's pi right here, right? So now you'll do 1. No, wait. Am I good? Okay. So then that's probably enough labeling for the test. Well, let's go out another 1, 2, 3, 4 units. So won't from here to here be another pi units? Yeah. So 3 pi halves plus 1 pi. Isn't it 7 pi halves? Yeah. And we could just do it in our calculator real quick. Okay. 5 pi halves, right? Yeah, we're good. I just couldn't do it in my head very quick. Okay, so that puts me at 5 pi halves. Okay, sweet. Then let's find the halfway mark. Here we go. 5, 6, 7, 8 pi halves, which is 8 pi halves, which is 4 pi. Then we'll divide it by 2, so that's 2 pi right here. Okay, that's probably good enough. So now let's draw in sine. So remember that sine starts at the 0, max, 0, min, 0, right? So here we go. Starting here, 0, next point, max, next point, 0, next point, min, next point, 0, right? Guys? Okay, drawing it again. Next point, max, 0, min, 0, and remember that sine's not really there, just helping us graph cosecant. Oops, come down here. Okay, perfect. Now remember that cosecant is really 1 over sine, so we know that sine of x cannot be 0. Look at my sine function. When is it at the value of 0? Right there, it's up at 0. 0, 0, 0. Anytime it crosses the x-axis, right? So that's where we put in our vertical asymptote. Anywhere it crosses the x-axis here. So much going on. Oops, kind of went in the wrong spot there. My shadow kind of blocked my view. And then because it's cosecant's a reciprocal of sine, frowns become smiles. Turn that frown upside down. Turn the smile into frowns. Questions on that? I know that was a lot to think about. It is. I'm not going to say it's not, because it is. Okay, good review. Okay, we're going to get to it. So, get out your homework from last time. I thought number 25 was pretty hard. So, we're going to go over it. So, your homework 6-9, 25 is what we're going to go over. So, what makes this one so hard is it gives us very specific instructions here. If it didn't give us this specific of instructions, there's many right answers for this. But it's pretty specific here. So, it says find the values for B for which the triangle has an angle A of 36 and side A of 5. So what makes this so hard is we're given angle A and side A, and so we've got to kind of go through and see what we're looking at here. So what I want us to do is just think of what we learned last time. So I'm going to draw a picture. So we're given an angle. So we're given angle A, right? Given an angle and a side across from it. So we call this side A, right? This is side B, and then this is my height with a 90-degree angle, right, everybody? Okay, when do we have one solution? Let's just talk about it in terms of A right now and go through, because we know when there's one solution. So it says find the values, and we'll go through and convert it to B in a second. So it says find the values for which we have one solution, two solutions, and no solutions. So when do we only have one triangle? When do we only have one triangle? Yeah. When A is larger than B, good, right? Is that when we have one triangle, guys? If it's longer than B, is it going to touch down somewhere over here and then wrap around and never cross again, guys? Okay. If A equals B, if A equals H, and also if A equals B. So if it equals H, then look, it's going to be one right triangle. If A equals B, it's an isosceles one triangle, right? Because as that wraps around, won't it hit perfectly there again? Does everybody remember? Okay, let's move on to two solutions here. So when are we going to have two triangles? If A is greater than the height, that way it comes down and crosses, but smaller than B, because then it crosses again and doesn't come outside. Does that make sense, everybody? So if A is greater than the height, but also A is less than B. Questions on that? Then also, when do we have no solution? If A is shorter than H and A is shorter than B as well, right, everybody? Because then if it's shorter than H, it swings down. If it's shorter than B, it's swinging like this and never can cross. Okay, so now it wants us to, it gives us some information here. It gives us angle A of 36, so let's put that in, 36 degrees, and it gives us side A is 5. So it wants very specific instructions, and it wants all of our answers for B. It doesn't want height, it doesn't want A, it wants every answer in terms of B. Okay, I'll give it to him. Okay, so continuing this, here, first of all, I want you to notice something. If I go to angle A and I look at height and B, can't I set up a sine ratio? Sine of 36 equals H over B. Isn't that a true statement? So we want our height in terms of B, because we want all our answers in terms of B. So to get height as a function in terms of B, we need to get height equal to an equation. So wouldn't we get height alone by multiplying by B? So H is the same thing as B sine of 36. Do you see how now we have H as a function of B? Everybody good? Okay, so let's go in and fill this in so that all of our answers only contain B's. Does that make sense? What's the length of A? 5. So we have one solution if 5 is larger than B for this particular triangle. If A equals H, so if A equals our height, but we need it in terms of B. So if A equals, which A is what? Sorry, what's A? 5. So if 5 equals B sine of 36, that's also when we have one solution. And if 5 equals B, right? So let's just write that all pretty style. So let's write it as one answer here. Well, kind of two. So couldn't we combine these two into one answer here? So my final answer will be in pink. So if B is, now this is less than, if we're going to read it backwards, right? If B is less than 5 or equal to 5, then we get one solution, everybody. That was one of the answers in the back of the book. You see how they're just converting it all in terms of B. And then also, if we divide both sides by sine of 36, then it's also true that we have one solution if B is equal to 5 sine of 36. So that would be your answer for one solution. That was kind of hard to figure out how to go about that, I'm not going to lie. Yeah, it was pretty hard to just go about it. Okay, let's move on to two solutions. So let's put in what we know, because this is very specific. It wants all the answers in terms of B. It gave us A. So A is 5, right? So 5 is greater than B. We're going to have two solutions. And if 5 is less than, greater than H, my fault. Okay, let me start over. So if 5 is larger than H, which is B sine of 36, right? And if 5 is less than B, so we need our answer in terms of B. So let's solve for B here. So we have 5 divided by sine of 36 is greater than B. So let's write our final answer in one kind of answer. So let's write this together and let's think very carefully how we rewrite this. If we read this way, won't that be B is greater than 5? So B is greater than 5, and B is less than that, right? Yeah. That's when we have two solutions. So if B is greater than 5, but less than 5 over sine of 36, then we get two solutions. So that was our answer for 2. Kind of hard. Then, no solutions. Let's put in what we know. If 5 is less than our height, which we need to write it in terms of B, so that was B sine of 36. And if 5 is less than B, so if 5 over sine of 36 is less than B, and 5 is less than B, aren't these both less thans? Okay, so we are not going to need to list both, because one of them is going to be greater than the other, if that makes sense. So calculate that decimal. 5 divided by sine of 36. Type it in your calculator. 8.5 approximately. So what we have is this. We have, and I'm going to read it backwards because I like to read my answers as B is greater than. So B is greater than 8.5. We get no solutions. And if B is greater than 5. So do you see how I just rewrote it in the like a prettier way of saying it, B first? So now, do we need it? If it's greater than 8.5, it's obviously greater than 5, right? So that's an unnecessary thing to list, so we wouldn't list that. So then we would just say, we have no solutions for B values that are greater than, instead of 8.5, we would leave it as 5 over sine of 36. I had some of Mr. Roberts' students come to get help on that one, and that's when I realized just quite how hard it was, just because it was like, what are they trying to go for here? Does that make sense, everybody? Does that help for those that had a hard time with that one? Okay, awesome. All right, that is it. So I'll give you a second if you want to turn that. See what we learned last time, real quick, very quickly. So last time we learned how to solve for missing angles and missing sides of non-right triangles. We used the law of sines. So remember, we can use the law of sines when given an angle and two sides, as long as one of the sides that's given is across from the given angle. Now, depending if that side is larger than the other given side or smaller, that's when we have to think about if we have more than one triangle, right? But look, from the given angle 110, the side across, which is 20, is larger than 15. So larger than the other given side. So isn't this the only triangle? Remember, we just talked about that, guys. We just went over that, how if the given side across is larger than side B, it's going to swoop around and only cross in that exact one spot, right? I can't tell, some of you will look not convinced. Guys, if this side is across from this given angle and it's much longer, won't it only give us one triangle, guys? Okay, you didn't look convinced. Okay, So now we can set up the law of sines. So remember, I like to put what I'm looking for on top. So we would say sine of x, sine of angle x over 15 equals, you can just watch, sine of 110, but you should have a calculator out ready to go, over the side across. So let's see if my algebra, I'm not going to go for it. I can do this in my head. If you can't, you'd multiply by 15, right? Take the sine inverse. So sine inverse of 15, sine of 110 over 20. Type it into your calculator. Now, everybody should do it so that if you get a different answer, you can say, I didn't get that, because we don't want to just believe the person next to us, because they might be wrong. X is 44.8 degrees. Did we all get that so we can agree? Okay, cool. Moving on then. If we all got it, we're good. Okay, looking at this one, notice we can use the law of sines when given two angles on any other side. Here's why. If we're given two angles, we can easily find the other angle. So 180 minus 30 minus 100 is 50 degrees, right? And now we can set up the law of sines. We're trying to find this side x, so you would say x over sine of the angle across from it, so sine of 30 equals, we're going to want to use this since we have that information, equals 30 over sine of 100. So then from there, x will be 30 over sine of 100 times sine of 30. Go, type it in. Everybody else get the same thing. 15.2. Now that was a side length. Perfect. Sweet. That's when we use the law of sines. And that brings me to the law of cosines. We've already gone over that. With the ambiguous case, we can have 1, 0, or 2 triangles. Okay. This brings me to the law of cosines. Here we go. Okay. So first of all, if we can't use the law of sines, that's when we use the law of cosines. But we only want to use the law of cosines if we can't use the law of sines. Because the law of sines algebraically is much quicker and faster. Okay, so you will use the law of cosines if you are given 3 sides and no angles. So if we're given 3 sides and no angles, we can go through and find any angle here using the law of cosines. We always start with finding the largest angle. So we're able to go through and find missing angles given all the sides using the law of cosines. So you can also use the law of cosines if you are given the information in the order of side, angle, side. That's because we can't set up the law of sines because we have too many unknowns here. So notice we're given 10, the angle in between, and 15. We could find the area of that, but we couldn't find missing angles and sides. With the law of sines, we'd have to use the law of cosines. So the law of cosines would allow us to find this side. And then after that, we would absolutely opt for the law of sines because it's going to be way quicker. So this is the different forms of the law of cosines. So a couple things to note. Angle A is written, angles are written once again in capital letters. Sides are written with little letters. And this is all 3 different formulas. So I wouldn't even write those down because that's too much to write down. Like, once you see the pattern happening, you could write down what I wrote down here. But you should really just see the pattern. I don't have the formula memorized. And every year I don't have to relook at it because I just remember the pattern that happens. So first of all, while you're, don't write it right now, I want to show you some things and then I'll give you time to write down the formula. So notice a couple things. If we're trying to find a missing side, like side A, that's what always goes on the outside. So then notice I call it on the outskirts of town, we have cosine of angle A that corresponds to side A. So if we were trying to find angle A, then the outskirts of town would have to be side A. Does that make sense? If we are finding side A, then the outskirts of town would have to be angle A. Everybody good? So look, we're trying to find side B. The outskirts of town will have a cosine of angle B. Yeah, you see how they're corresponding. So side C and cosine of angle C. So this formula works like this. If we're trying to find, like for example, side A. So you'll do A squared equals, it's the other side squared plus the other side squared minus 2 times that side, and then cosine of the angle across from the outside there. So notice, like this thing, A squared plus C squared minus 2 times that. You're just going to hear me say that every time. See, look, A squared plus B squared minus 2 times that. Do you see how that's just a pattern? So instead of memorizing the formula with A's and B's, I kind of just think of it like this. So side 1 squared equals side 2 squared plus side 3 squared minus 2 times side 2, side 3, cosine of side 1's angle. So that's side 1's angle. So you just got to really notice the pattern. So I'll give you a second if you want to write down some form of the formula, but I'm never going to even write down the formula again. I'm just going to go for it. As you're writing it down, notice a couple of things. We're given 3 sides and no angles. This is one of the times that we opt to find the angles using the law of cosines. We're going to want to start with the biggest angle here. So let's go ahead and start with angle B, because notice 19 is the largest side, so my largest angle will correspond, which is angle B. So that's where we're going to start. Now, if we're trying to find angle B, then our outskirts of town is going to be cosine of B. So this 19 has to be on the outskirts of town too. So we're going to have 19 squared equals the other side squared, 8 squared, plus the other side squared, 14 squared, minus 2 times that, times cosine of the angle that we're trying to find. So cosine of B. So notice in that equation I only have one unknown, that's B, angle B. So we're going to do some algebra to get B alone. I'm going to show my work here because a lot of times people do some weird things. So 19 squared is 361 is equal to, I did add those up, it's addition so we can put them together. If you add that up we get 260. Then we have minus 2 times all that stuff, so I'm going to multiply that together. So I get negative 224 cosine of angle B. So notice I just kind of am doing some algebra to put some things together. Now let me tell you what a regular student does a lot of times. So in regular, this is what we see. We see students go that, and they combine them. No, right? Like, we would never do that. Okay, good. So that would be incorrect because it's multiplied to that. So now we would subtract 260 from both sides. So what we're going to have here is 101 equals negative 224 cosine of angle B. So our next step is divide both sides by negative 224. 101 divided by negative 224 equals cosine of angle B. So now to get angle B alone, we would take the inverse. So angle B will be equal to cosine inverse of 101 divided by negative 224. Type it in. So did I. 116.8 degrees. Okay, questions on that? Now from here, what we're going to opt for is the law of sines to finish finding the other angles. So let's go ahead. I don't care which angle we find. I'm just going to say C. Randomly choosing C. So if I'm finding angle C, that's going to go on top. So we'll say sine of C over the side across from it, 14, equals sine of 116.8 over the side across from it. Now it's algebra to get C alone. So angle C will be sine inverse of 14 sine of 116. And once again, if it took you a second to go through and do the algebra, that would absolutely be fine. So angle C comes out to be, is that too fast, or does everybody feel pretty comfortable at this point with something like that level? Because that would be way too fast at a regular one. 41.12. So let's go with 41.1. And now we're going to do the easiest way to find angle A. We're going to do 180 minus 41.1 minus 116.8. So we get 22.1, and we have solved the triangle. Yay! Okay, let's do another example here. Okay, so it says find side A. Luckily, we're not solving the entire triangle in this one. Finding side A. Notice we'd have to use the law of cosines because we're given two sides and an angle where the angle is not across from a given side. So now I'm going to write in A. So remember, because we're trying to find A, that's on the outskirts of town. So our algebra is going to look like this. A squared equals one of the sides squared plus the other side squared minus 2 times that times cosine of the angle across from the missing side, across from the outskirts of town. You see how these correspond? Yeah. Cool. Now look, over here there's no unknowns, so you can just literally type it into your calculator. I want you to do that. Everybody go. Good. When you type that in, you should get 451.79. Now that's a squared. So from there, we would square root both sides of the equation. We should get a is equal to 21.26. Cool. We found side A. If we were asked to continue solving, we would then just use the law of sines to find those other angles. Just because it's quicker. To find one of them. And then 180 minus. Okay, cool. Questions? Okay, this is no questions then. Okay, awesome. So what we're going to do is do an example out of the book. And I drew it up here and I didn't draw very good. So I did my best. This is supposed to be a square, a perfect square, which is definitely not. It's roughly somewhere close to 443, but in the notes. So the reason we're going to go over this one is because I went through and started doing some of your homework problems, and there was a problem where they talk about diamonds and baseball fields and they don't give you the picture. And then I was like, well, they don't have enough information. But it's because we're going to talk about what they'll let you assume. So we're going to talk about that. So if we didn't have this picture and we just read this, we'll talk about what we'd be missing. So it says, the pitcher's mound on a women's softball field is 43 feet from the home plate. So you have to be able to draw this. So here's the women's softball pitcher. This is the home plate, right? This is 43 feet. Okay, good. Now it says the distance between the bases is 60 feet. So as around this square is 60 feet. How far is the pitcher's mound from the first base, it says. How far is this pitcher's mound from first base? So that's why, and then they say refer to the picture. So notice looking at our picture, there's a lot more information. They gave us a 45-degree angle, right? Which didn't say anything about that up here. No, but here's the thing. You're allowed to assume, because do you see how this is the corner of a box? That's 90 degrees, right? We're allowed to assume that if we drop this down perpendicular, meaning cutting it perfectly, and well, dropping it down perpendicular, it's going to cut it into 2 equal segments, which makes that a 45-degree angle right there. Bisecting it. That's the right word for it. So everybody see what's happening here. So if you're given a baseball problem, you can assume that angle is 45 degrees. No. Just from here to here. Just from here to here. Okay. Now, fun fact, we cannot say that that is, we can't say that this is 43. We've got it, so look at the information, now that we're looking at the information, and interesting enough, if you know anything about, some of you do know things about baseball and softball, apparently this distance from here to here is just a teeny bit further than from here to here. Okay, so let's do the algebra to show that. So we are given 2 sides and an angle that is not across from a given side. So here we go, law of cosines. We're finding x. So we'd say x squared equals 43 squared plus 60 squared minus 2 times 43 times 60 times cosine of the angle 45. So now you would calculate all of that stuff, you would type it in, and you should get 1,800.3 roughly. And we're not done though, because we need to square root it, luckily, or else that'd be very long. So x is equal to square root, you would get 42.43. So 42.43, so it's just a teeny bit shorter. Everybody good? Okay, awesome. So in your problem on the homework that I assigned, we will be able to call that angle right there and that angle right there 45 degrees. Cool, okay. Next example. So this is in your book, but really if you look up here, I have a pretty good picture. So it says, a ship travels 60 miles due east, then adjusts, it's supposed to say adjust, but whatever. Then adjusts its course northward as shown below. After traveling 80 miles in that direction, the ship is 139 feet from its point of departure. Describe the bearing from point B to point C. So first of all, most of the time they don't give us the picture, and that's usually the hardest thing to draw, so let's kind of think through it, okay? So if we have a starting point, it says A ship travels 60 miles due east. So look, here's north, south, east, west, right? So do you see how starting out I'm going due east? Here's my ship going. It says after 60 miles, it turns northward. And then so it turns and goes northward in the north direction. And it goes for 80 miles in that direction till it hits here. There's my ship. It says then from there, from that point to the point of departure, which was point A, it was 139 miles. What it wants is the bearings from point B to point C. So what we're going to do is go down to point B and draw in a north, south, east, west line. Okay, looking at that, everybody. Do you see how this is north, south, east, west? So what it wants is the bearing, and bearing always goes from the north off somewhere, either east or west. Does everybody see? So what this is really looking for, guys, is in particular this degree. Does everybody understand why? That's how bearings work. They start at the north and then curve and go. Does that make sense, everybody? Yes. So what we're going to do is say, well, look at this. We have this big non-right triangle. Can't we use, since we're given 3 sides, the law of cosines to find that obtuse angle? Let's do that first, because once we have that obtuse angle, we can figure out the rest. Here we go. So let's call that angle B. So outskirts of town is 139. So you'd say 139 squared equals 60 squared plus 80 squared minus 2 times that. And then cosine of B. Go for the algebra. So I did show some work here. If you calculate that, I get 19321 equals, I added those up and get 10,000. And then I multiplied those minus 9,600 cosine of B. So now solving here, we would subtract 10,000, 9321 equals negative 9600 cosine of B. So then from there, B is going to be equal to, I can see it in my head, I would divide that over, right? Then take the inverse. So we'll have cosine inverse of that, 9321 divided by negative 9600. Type it into your calculator. Okay, did we all get it? Okay, so that big obtuse angle is 166.2. So now we can use that information to figure out just that angle. There's many different ways we could do this. I like that. This is 90, so we'll take that, minus 90, and that will give us that leftover. So that is 76.2. So this little angle is 76.2. Does everybody see why that would work? Okay, so we would say 76.2 degrees. Now it starts north. You always say north, and that's in the eastward direction. So that would be our final answer. Okay? Okay. No. You'll be okay with that one. Okay, last one. Last example. So everybody, if you are interested, you can go to your book, page 24. It's not on your homework, but it's very similar to some that are on the homework. So page 443, number 24. So I'm going to show you 2 different things here because it says use Heron's formula to find the area of the triangle. However, in my opinion, like, why have to memorize more formulas? We already know a formula that works, so you could just use that. So that's what I'm going to do first, and then I'll show you Heron's formula, okay? Okay, because when I go to the ACT, I don't want to have to remember 20 million formulas. I just want one that will work for everything. Does that make sense? So the area for a non-right triangle, or even a right triangle, is 1/2 times side 1 times side 2 times by sine of angle between. Guys, we learned this last time, right? You did your homework, you did practice some of those. So let's draw this triangle. We've got to be able to draw it correctly. So angle ABC is what I'm going to put in first. Side A is 12, side B is 15, and side C is 9. So we need an angle in between any side, right? So let's go ahead and find this angle B. So we're going to have to find an angle to be able to find the area, which is fine. Let's just use the law of cosines real quick. So we would have the outskirts of town needs to be that. So 15 squared equals the other side squared plus 9 squared minus 2 times 12 times 9 times cosine of angle B. Calculate the angle. Everybody, this one's interesting. You should calculate it. Because it always throws people off. Whoa. Okay. Did you get a 0 here?
Yes.
0 is equal to negative 2 times 12 times 9 cosine of angle B. So if you divide both sides by that, I'm just going to put that because I don't want to rewrite it. And 0 divided by that, B 0. So we have 0 is equal to cosine of B. So then B is equal to cosine inverse of 0, right? 90 degrees. Okay, so this is 90 degrees. So let's now find the area. Area is equal to 1/2 times side 1. Yeah. 1/2 times base times height?
Yeah.
You could do that, yes. But I'm just going to keep going with this. Because what if it wasn't 90? Let's just go for it. So area is equal to 1/2 times side 1, which is 9. This is almost just as easy. Times side 2, which has to be 12, right? Times by sine of 90. Type it into your calculator. We get area is equal to 54. Did you get that? Okay, I'll show you Heron's formula for those of you that are interested in it. If not, you can, even if it says use Heron's formula, that formula always works for all areas of triangles. Okay, so Heron's formula, though, I do want you to see. Okay, so what Heron's formula is it allows you to find the area of any triangle if you're given just all the sides and no angles. So Heron's formula, once again, allows you to find the area of a triangle given all the sides. Yeah, it is kind of cool. Okay, so here's the formula. Area is equal to, this is given all sides, no angles. You don't have to know angles, but you have to know all the sides. So area is equal to the square root of S, and I'll tell you what S means in a second. S minus A times S minus B times S minus C. But to find that, you would first calculate S, which S is its own formula, side A plus side B plus side C divided by 2. That's the formula. So we could use that because we're given 3 sides, no angles. So our area is going to be equal to, well, first we need to find S. So S is equal to 12 plus 15 plus 9 all over 2. So S is 18. So now we can plug it into the formula. We have an 18 times 18 minus 12 times 18 minus 15 times 18 minus 9. So you should get the area is equal to, underneath the square root, we get 2916, and area is equal to 54. So there's 2 ways we got to the same answer. Like I said, if you want to use that formula, great. If you just want to keep in your mind, I like that. I mean, I only want to have to memorize that one formula that works for everything, because you know what I mean? That's good enough for me. Do it however you want. Okay. That is it. So these are the problems. So the rest of the time is yours. You need to be working on math. My class math for this group that always has something to say about math.